everybody, so regular viewers of the channel will know that I'm fascinated and interested in everything to do with about energy, including generation. And one of the things that one of the unsung heroes of generation are Stirling engines. We tend to think about Stirling engines in a certain way, and they are misconceptions. We believe that they can't produce a lot of power, and we believe that they're inefficient, and nothing could be further from the truth. It was in the late 70s when the DOE tasked NASA with creating a Stirling engine that would run a car. In 1989 they dropped it into an AM Spirit, then they went on and dropped it into a Dodge van, and then they dropped it into a Chevrolet. So they've made these engines, put them in cars and done tests on them to show that these engines are in fact incredible in the way that they can behave. Now, a Stirling engine is an external combustion engine, and it grew up round about the same time as steam, with one huge advantage. Steam uses a boiler, and boilers are inherently very dangerous things and need skilled people to run them. The Stirling engine got rid of that by heating the cylinder with the fire on the outside, and that made them tremendously safe. And they were very, very popular about the time of steam engines, and competed directly with them. They kind of fell by the wayside, and when we got diesel and petrol engines, of course, nobody really looked at them again until the 70s. And now there's a resurgence of interest in them because Stirling engines can be run by anybody. It's mechanically very simple and incredibly safe to operate, which you can't say about a lot of other engines. And of course, on the channel we've done whole load of videos about various kinds of Stirling engines and heat engines, and these are some of the ones that we've done. Look at that bad boy go! Let's have a close-up. Isn't that awesome? Okay, that's awesome! Now you might notice I've surrounded it with rock wool because having a bit of a chilly breezy day, and we couldn't get it up to temperature without a bit of insulation, so it does need insulation around that firebox there to maintain that temperature difference. But once you get the thing going, it's like a beating heart. It's really quite cool actually. Obviously what we need to do is put the magnet on there and stick a coil around it, but I just wanted to show you that the rocket stove will drive that Stirling engine, and it's just plain awesome. We'll take it apart so you can see how it's made. Now on the top we've got a lump of metal which acts as a weight, so effectively that's like a flywheel. And then there's a magnet on there just holding the whole thing together, so it just holds it on the rubber band. And that is just a button of rubber, and what we've got here is a balloon. So if I take this off, then inside what you'll see is the other side of the balloon that I stuffed a screw in. So that screw clips. There we go. That bolt sits on the underside of the balloon, and at the end of the bolt is a very, very tiny magnet. Because in here is a displacer. That magnet hits the displacer, picks it up. As the balloon expands, it lets go, and the displacer drops down. So all it is that bouncing up and down, which is kind of cool. And in here is the displacer, and you might see a retaining ring. Let me get that ring out for you. Okay, that's it. It's a bit of MDF. In there we have our displacer, which is wire wool wound around, a couple of tin plates either side, and sewed together with a bit of copper wire so it's free to bounce up and down. This obviously stops it, and it's put at about 5mm. So what happens is the magnet grabs hold of the tin plate, and as the balloon expands it comes up until of course the balloon pulls it away when the displacer drops back down. That means of course that the air is now pushed into the cold side, and the balloon goes back down, and as the balloon goes back down it grabs the displacer, and it continues with that. And that's how the engine works, which is stunningly simple. I mean, no linkages, no engineering, made out of a baked bean can and a bit of wire wool, and these magnets, they're tiny. You don't want it so that it holds that too much, you just want it so that it can pick up the displacer, and when it comes to the retaining ring, it doesn't have enough force to hold it. It's quite gentle actually to pull that off, so the displacer will fall back down by gravity. Yeah. And that, believe it or not, is a thermoacoustic engine called a Hoffler Tube. Now all we have to do is to get it to run. When it runs, then it will hum. There's all of these tubes, when they're working, hum. And then changing it into an engine is a bit different, but not that much, because what we get is a vibration here. And essentially you stick a diaphragm or a piston on this end here, and that vibration is translated into the piston. Now what I've got here is a methylated spirits burner. And I also need my lighter. One of the excruciating things about these tubes is how long they take to heat up. Not so with the Hoffler Tube. We just heat up the end there of the stack, which is what that steel wool is. Give it a few moments and we should hear it hum. There we are, humming away. How easy was that? A stunningly easy thing to make, actually, in the basis of a Stirling engine. I wanted to show you the tube. It's very often when you try and make these Stirling engines, if you don't try and make the tube first, you wonder where you've gone wrong. So making this tube that resonates is actually the first step to making that engine. So a Hoffler Tube, which was used in refrigeration by NASA, is stunningly simple, non-critical, really easy to make, so it'll hum away all by itself as long as that method is burning. That in isolation, obviously. What I've done is I've done some videos and other people have given me helps and suggestions and hints, which is the kind of way that I tend to develop stuff anyway. But there's one guy I'd like to bring to your attention because he runs a YouTube channel called Blades World and it has 12,000 subscribers. I can't believe that. I think it's one of the most undersubscribed, brilliant channels that there are out there. So I'm going to put a link to Blades' channel at the end of this video as a click-through link. Click through, and if you want to know anything about Stirling, that guy is an absolute genius, and he has one other really good trait about him. He's incredibly generous with the help that he'll give. So he's given me a ton of help to help me develop the things that I've been doing. And I know that Nighthawk in Light, when he did his thermoacoustic engine, relied heavily on Blade, and Blade just helped him. And Nighthawk says this in his video. He gives the guy credit, okay? He says this in the video. But Blade doesn't do anything about this. He really just plugs along doing what he's doing. And he's very, very generous with the help that he gives. Now, he is running a competition, and again, I'll put a link to his competition video at the end of this video so you can click through and see the competition and the competition rules. But it is basically to create a Stirling engine, put it on your own channel with a hashtag, and that will become a competition entry. Now, the competition started 10 days ago, and I noticed it, and Blade wrote to me and asked me if I'd mention it, and which I've just done. And I was going to do my own version of it, but I think by the time I do it, it'll be so late that you won't get the competition notification. But what I'm going to do is the magnetically assisted Stirling engine that we did. We did a short on it, and what I'm going to do is make a real version for you so that you can see how to make the magnetically assisted version, but this is basically it. Anyway, I'm hoping that you do jump over to Blade. Like I said, the guy's an awesome guy. His competition looks really interesting. I would create an entry if I thought I could get it there in time, but I don't think I will. And I hope you enjoyed this video. Thank you very much for watching, and please do remember to like and subscribe.